Topic is the modulation technique, subject of the principle of communication. Now we discuss about the what is the digital modulation. In digital modulation, an analog carrier signal is modulated by a discrete signal. So the digital modulation can be considered as a digital to analog and corresponding demodulation as analog to digital conversion. So in digital communication, signal convert into digital form to analog form, and but in demodulation system, the signal convert into analog to digital conversion. So in digital communication, the modulating wave consists of binary data and the carrier is sinusoidal wave. There are different digital modulation technique which is represented by in the form of different waves. So there are types of digital modulation techniques. First one is the baseband digital message signal, which is represented by the MT or message signal. So this is the base signal, and the second one is the analog sinusoidal carrier signal. This is the high frequency signal, represented by the in the form of cosine wave AC cos 2 pi fct plus phi c. So this is the high frequency carrier wave and represented in the second waveform of the this diagram. Third one is the ASK, amplitude phase shift key. A message signal change the carrier's amplitude in this amplitude shift key system, and this ASK signal is represented by the waveform number third, in which the amplitude is changed as per according to the time. Fourth one is the FSK, frequency shift key. In frequency phase shift key, a message signal change the carrier frequency. So here the frequency is changed in the FSK signal, which is in the waveform number 4. And number 5th is the PSK, phase shift key. A message signal change the carrier in phase in PSK signal or phase shift key modulation technique, in which the phase shift is changed with the time. In amplitude phase and amplitude shift key, in ASK, the amplitude of the signal is changed in response to information and all else is kept fixed. What one is transmitted by a signal of one particular amplitude to transmit 0, we change the amplitude keeping the frequency constant. So in this ASK, the frequency remains constant, but the amplitude of the signal is changed, and you can see this change in this waveform presentation. Frequency shift key FSK. In FSK, we change the frequency in response to information. So one particular frequency for a 1 and another frequency for a 0. So in this, the signal converted into discrete form or 0 or 1 form. And here the frequency change in the FSK modulation system. So we can see in this different waveforms. There are carrier signals and modulated signal. In modulated signal, the frequency is changed as per the carrier signals. Next is shift key. In PSK, we change the phase of the sinusoidal carrier to indicate information. Phase in this context is the starting angle at which the sinusoidal start. So one phase change encodes 0 while another phase change encodes 1. To transmit 0, we shift the phase of the sinusoidal by the 180 degree. So this is the phase shift key modulation technique. M-array modulation technique in binary data transmission. Send only one of two possible signals during each bit interval, that is the interval TB bit interval. In M-array data transmission, send one of m possible signals during each signal interval duration of t. In almost all application, m equal to 2n and t equal to ntb, where n is the n integer. So each of the m signal is called the symbols, and these signals are generated by changing the amplitude, phase, frequency, or combined form of carriers. Thus we have MASK, MPSK, and MFSK, and MQAN. So in that M-array modulations, the each of signal is called the symbol, and almost data transmission send one m possible signal during each signal interval of time t. In quadrature phase shift key QPSK, quadrature phase shift key can be interpreted as two independent BPSK or binary phase shift key systems, and thus the same performance but twice the bandwidth efficiency. In this QPSK systems, the phase of the carrier takes an 1 or 4 equally spaced value, where each value of the phase 0 phase, pi by 2, pi, and 3 pi by 2 phase equal pair of the message weights. In quadrature amplitude modulation QAM, if both the amplitude and the phase are very proportional to the information signal, that is the quadrature amplitude modulation system, in which amplitude and phase are very proportional to the information system. Information signal may be message signal, modulating signal, or data signals. Quadrature amplitude modulation result combination of phase shifting, the amplitude shifting. So we can see the quadrature amplitude modulation in the form of different waveforms. So first is the carrier waveform, and second one is the modulating value from 3 bits, which start 00, 110, 001, and 11. These are the in form of digital, but the equivalent to this digital value 000 equal to 0, and 110 equal to 6, and 001 equal to 1, and 11 equal to 7. So modulated resulting wave here in the second waveform, that is the quadrature amplitude modulation. In differential phase shift T, for the perfect detection of a phase modulated signal, the receiver need a reference signal. What its differential encoding and phase shift key are made together at the transmitter. The technique is called a differential phase shift key DPSK. For the transmission of a symbol 0, the phase is unchanged, whereas transmission of symbol 0, the phase of the signal is changed by the 180 degree. This is the for the differential phase shift key modulation system. In DPSK, the phase shift is with reference to the previous bit transmitted rather than to some constant reference signal. So there are two uh, representation of the DPSK in the form of uh, digital waveform and the sinusoidal waveform. So this waveform show the DPSK modulation technique. Matrix for digital modulation. What is the power efficiency? Power efficiency is a measure of how much signal power should we increase to achieve a particular bit rate error VER for a given modulation scheme. So the ability of a modulation technique to preserve the fidelity of the digital message at low power. The designer can increase noise immunity by increasing the signal power. So we can uh, uh, increase noise immunity by increase the signal power. So the noise immunity depend on the signal power. Bandwidth efficiency, basically bandwidth is the path of way of communication of a two particular frequency difference. So ability to accommodate data within a limit of bandwidth, the trade-off between data rate and pulse width. So easy to implement and cost effective to operate for the merits of digital modulation technique. Next type of digital modulation technique is the delta modulation. So what is the delta modulation? A delta modulation is an analog to digital or digital to analog signal conversion techniques used for transfer data. So in delta modulation, we can change the analog signal into digital signal or also digital signal to analog signal in delta modulation technique. So this is the delta modulation technique, which is the digital type modulation technique. Why delta modulation need we? Why delta modulation need? Delta modulation is an analog to digital conversion, or delta modulation is simple form of differential pulse code modulation, or PCM. So the delta modulation used by satellite business system or SBS. So, so the need of delta modulation to achieve high signal to noise ratio for the delta modulation technique. And delta modulation can change instantly what voice signals can't not change instantly. So this is the very most important features of delta modulation. Delta modulation signal is smaller than the PCM system or pulse code system. So this is the some features to as compare the other modulation technique. So we see in delta modulation technique, here we see there are total uh, two waves and total, sorry, three waves. First wave is the original modulating or original waves, and second one is the integrated waveform, and third one is the modulated waveform in the delta modulation system. In first wave is the continuous analog waveform. What second is the form of uh, integrated form of continuous wave. What in third wave is the discrete form or form of digital of the delta modulation system. So we take the these waveforms amplitude versus time. So in delta modulation system, there are some waveform, and we understand and we clear the concept the delta modulation system. The demodulation block diagram of the delta modulation system. So in delta modulation system, there is a staircase marker and a input signal in the form of digital data 0101. That is the input signal in the form of digital data applied to the staircase marker, and one is also delay unit, which is to apply the staircase maker, and after the staircase maker, the output of this network applied to the low pass filter, and low pass filter pass the low frequency signal and stop the high frequency signal, and this signal is converted into the analog signal. So this is the demodulation process in delta modulation system, because in delta modulation system we can change the analog signal into digital signal. What that is the in modulation technique. What in demodulation technique, the digital data change into the analog signal or analog data. So this is the block diagram and the conversion process of the demodulation of the delta modulation system, in which digital data convert into analog signal. Simple implementation of delta modulation system. So in delta modulation system, in this block diagram of delta modulation system, there is the one device is comparator. Comparator, the function of comparator, compare the two signals which is applied to the input of this comparator. So we see here one signal is applied, analog signal at the terminal of A, and another signal applied to the terminal B. That signal is a provided by the integrator. So here is a comparator, integrator, and D flip-flop, and next the output of the comparator applied to the D flip-flop. So D flip-flop is the digital device. We apply to the D flip-flop a clock pulse in the form of time. So D flip-flop work as a uh, uh, as per the applied or as per the clock pulse, which is applied by the clock pulse in the form of digital. So this is the simple implementation of the delta modulation system, in which the analog signal convert into digital signal, or also the digital signal convert into analog signal. So this is the function of delta modulation and demodulation system. So this is the simple implementation of the digital delta modulation system. Now we see there how it works together, or modulator and demodulator, how to work its together. So in this block diagram, there is a comparator device, and one is integrator, and also one is integrator. So there are two integrators, one comparators, and one is the sample and hold circuit. and one is the low pass filter. So we divide it circuit diagram or block diagram into two parts. One part is we have as a modulator, and second part we have as a demodulator. In modulator part, in the part of modulator, we applied the two input to the comparator, uh, which is compare the two input signals. One signal applied by the direct from the outside, that is the input signal, and second is the feedback signal which is applied by the integrator, and also the output of integrator is applied to the comparator, and input of integrator is uh, feed by the adaptive logic device. So this is the part of the modulator, and this output of the comparator applied to the next integrator, and that integrator applied this signal to the sample and hold circuit, and this is the part of the demodulator uh, circuit. And next one, the signal applied to the low pass filter, and the function of low pass filter pass the low frequency signal and stop the high frequency signals. So output of the low pass filter is the delta modulated signals. So these are the block diagram representation of the both modulator and demodulator of the delta modulation system or modulation technique. Now we compare the pulse code modulation versus delta modulation. In block diagram of pulse code modulation system, we take the analog signal, and this signal applied to the a sampling network, and sampling network output to the quantizing network, and also a pulse train is applied to the output of the sampling network, and the output of the quantizing, there is a quantizing signals, and then this signals applied to the in the encoding, and we convert the analog signal into digital signal in the encoding network. So this signal converted into digital form or 0101 form. So this is the pulse code modulation system, in which analog signal converted into the digital signal with the help of sampling, quantizing network, encoding network, and pulse amplitude signal. So this is the conversion process in PCM system, and also in delta modulation system, the analog signal also convert into digital data. What in delta modulation system, we take here a comparator device, second one is delay unit, and third one is staircase maker. So there are total three networks which is used to convert analog signal into digital signal in the delta modulation system. So the input signal applied to the comparator, and another signal uh, applied to the comparator, that is comes from the delay unit, and this is delay unit receive the signal from staircase maker, or staircase maker receive the signal from the output of the comparator. So there is a establish a feedback concept, and the in this process the analog signal convert into digital signal or 1010 form. So this is the conversion process of the delta modulation system. So there are two comparison between pulse code modulation system and delta modulation system. Next comparison, PCM versus delta modulation. In PCM is a method used to digitally represent sample analog signals. What delta modulation digital to analog convert. Okay. Second one is encoder decoder, and in PCM system we use the encoder and decoder device. What in delta modulation we use the modulators. In PCM signal need encoded and decoded both sides. What in the delta modulation signal can modulate and demodulate. In PCM system large process, what in delta modulation easy process. So PCM is the very costly and DM system very cheap. So there are some difference between the PCM and DM. There are some limitation of the this systems of delta modulation system. There are slope overload, and when the analog signal has a high rate of change, so delta modulation can fall behind and distorted output occurs. So you can see the distorted output waveforms in when slope is overloaded. So this is the limitation of the these systems. Next, what is the sampling? So sampling, basically sampling is the theorem for the transmission of data in communication system. So sampling theorem, ideal sampling, flat top sampling, natural sampling, reconstruction of signal from samples. Lighting effect, upsampling and downsampling, discrete time processing of continuous time signals. So what say the sampling theorems? A continuous time band limited signal can be represented by its samples and can be covered from its samples. So provided that sampling frequency omega s, that is the sampling frequency, always greater than or equal to 2 omega n. So this is the sampling theorem where omega n is the modulating frequency, or we can say that the sampling frequency always greater than or equal to 2 omega n. So this is the condition or for the sampling theorems. So omega n maximum frequency of the signal, the condition is referred to as Nyquist criteria. So we see here, this is the sampling network, and we apply to this sampling network a continuous time signal GT, and after sampling this signal convert into discrete time signal G naught T in the form of digital. So this is the function of sampling, which convert the continuous time signal into the discrete time signal. So that is the sampling theorem. The condition for sampling theorem is the frequency of the sampling is greater than or equal to 2 times of the maximum modulating frequency of the signal. Now, ideal sampling in time domain, and we can explain in time domain and also in second frequency domain. So sampling in time domain result in conversion of continuous time signal into the discrete time signal. So this is we can understand these time domain sampling in the these are the with the help of these waveforms in which in time domain the continuous time signal converted into discrete time signal. What in the frequency domain system, the sampling result in multiple translation of signal spectrum, linear combination of shifted signal spectrum at integer multiple of sampling frequency. So second one is the uh, uh, frequency domain sampling. So there are two samplings, time domain and frequency domain, and these are the uh, representation in the form of waveform in which the conversion of waveform from one form to another form, or in the form of discrete or in the form of uh, frequency domain, frequency sampling. Now, ideal sampling reconstruction, or we want to now the digital signal convert into again analog signal. So this is the reconstruction block diagram of the sampling system. So we here have a low pass filter and a amplifier with gain of TS. So this is the reconstruction and block diagram in which the sample signal or discrete signal applied to the low pass filter and again applied to the amplifier and then convert into analog signal. So this is the reconstruction process of the mm, discrete signal convert into the analog continuous time signals. In flat top sampling, as ideal impulse can't be generated, practical sampling pulse will be exist for a duration. In flat top sampling, for each sample, the value is hold for a duration of t. So flat top sampling may be thought of as output of a system with impulse response and ST as shown in figure. Here is the ideal sampling network, and next one is the system with impulse response. So we apply ideal sampling network, a continuous time signals, and this signal convert into ideal samples in discrete form. That is the G naught T, and this signals again apply to the system with impulse response. And after the system with impulse response, the output will be flat top sample. That is the GT flat top signal. And so this is the flat top sampling uh, technique conversion. And this is the block diagram of the flat top sampling. In flat top sampling, introduce aperture effect as a per sample function. So there are different waveforms which is in continuous time form, and some are impulse train and some are sample signals and some top flat sample signals. So these different waveforms represent the concept of the flat top sampling. Next one is the natural sampling. In natural sampling, each sample is pulse of duration t with amplitude vary in accordance to signal value. Natural sampling may be thought of multiplication of signal with pulse trend. So we see in this block diagram, there is a natural sampling network, and natural sampling network, we apply to this network a input signal in the continuous time signal GT, and after the natural sampling, this signal also convert into the natural digital or discrete signal. So this is the natural sampling technique. What the in this process, the frequency is no change, but the time is change of the discrete output signal as per the input continuous time signals. So there is a variation of amplitude, but there is no change in time. So in natural sampling uh, technique, each sample is pulse of duration t, which is the duration of t. This is the equal for each pulse. Amplitude vary in according signal wave. So here is amplitude is vary according to the input signal. So the natural sampling may be thought of multiplication of signal with pulse trend. So in natural sampling, we understand the this natural sampling by the different uh, graph representation. So natural sampling introduce amplitudes scaling as per sample function at every shifted version of g omega, and note the aperture effect as in plateau sampling. So here is input continuous time analog signals, and the output is the natural sampling in the form of digital or in the form of impulse, or also in the form of pulse train. What in pulse train, the frequency and amplitude remains the constant, as you can see this in second waveforms. So there are the different waveforms of natural sampling technique. Now we discuss about the upsampling and downsampling. In downsampling, decimation, subsampling a discrete signals. There is discrete signal or digital signal, and we can see this in the waveform number third, in which the signal in the form of discrete, and in that signal the frequency or time duration is remains constant, but the amplitude of the output signal or discrete signal is changed with the input signals, that is the continuous signals. And the upsampling introduce zero between samples to create longer signals. So in the waveform number third, that is the upsampling signal representation of output of the upsampling, in which also the amplitude is changed, but the frequency is not changed. Frequency or time duration is unchanged. So there are wave representation of the upsampling and downsampling techniques here in this different waveform graphs. Now, discrete time processing continuous time signals. Continuous time signal can be converted into the discrete time. This is the process of conversion. That is the convert analog signal into the digital signal by using the sampling and quantized to make it digital. So this is the digital conversion technique. And these discrete time signals can be processed using computer-based discrete time systems, and output can be reconstructed as continuous time signal, or also in reconstruction process again a digital signal convert into analog signal. So in this block diagram there is a analog to digital conversion, or a signal applied to the input of this network, that is the analog signal. That signal convert into the from analog form to digital form, or by the sampling process or quantized process. Then this signal is applied to the again next to the discrete time system network, and this network convert the signal into the digital form or different impulse form, that is the form of digital. And after this discrete time system, the signal is again applied to the D2A converter or digital to analog converter. This is the demodulation process in that network, because here the digital signal again converted into the analog signal. So this network D2A converter or reconstruction network, at the output of this network the signal will be in the form of analog. So first of all we convert the analog signal into digital signal, and digital signal also convert again into analog signal. So this is the process of modulation and demodulation in the process of the discrete time processing of continuous time signals. So these are the some digital modulation and demodulation techniques. And these are the reference books. First one is the analog communication by the Hart and Raab. Second book is the digital communication by the TL Shingal. So these two books cover all the this topics. And there are 10 questions of multi-choice. So question first, what are the primary feature of a transmitter? So option A, lower clock speed, B is the lower transmitting power, C is the high clock speed, D is the none of these. So correct answer is D, because in the feature of transmitter, lower clock speed not used, and lower transmitter power not used, and high clock speed not used. So the correct answer is D. Question number second, the window gives a number of bytes. Option A bytes, option B frames, option C both, option A and B. So the window gives a number of bytes and frames in digital communication system. So correct answer is option C. Next question, Number third, which of the given device does the data comparison? So option A, switches, B is the circuit breakers, third is the microcontroller, and D is the source encoder. So correct answer is the D, which is the source encoder. Question number 4, space loss occur due to a decrease in phase shift. Second option, momentum. Third one is electric field strength, and fourth one is power. So the correct answer is electric field strength. Question number 5, the power spectral density of a signal is option A, even, negative and complex, option B, odd, complex and positive, option C, real, odd and negatives, option D, real, even and non-negative. So option D is correct answer. Question number 6, a modulator is a device used to option A, differentiate two frequencies, option B, amplify two radio frequency signal, option C, impress the information onto radio frequency carrier, and option D, reduce the modulating power requirements. So correct answer is the D. And question number 7, a balanced modulator is used in the generation of which of the following signals? Option A, frequency modulation signal, option B, DSB SC signal, option C, ISI signal, and option D is the SSB SC signal. So correct answer is the option D, double sideband suppressed signals. And question number 8, which of the given modulator is an indirect way of generating FM? So option A, inductance APT modulator, B, Armstrong modulator, option C, reactance 2 modulator, and option D, Zener diode modulator. So correct answer is B, Armstrong modulator. Question number 9, in FM modulation, when the modulation index increase, the transmitted power, option A, half, option B, decrease, and option C, double, in option D, unchanged. So the correct answer will be unchanged. And last question, in phase modulation, phase deviation is proportional to which of the following? Option A, the wavelength of the message signal, option B, the message signal, option C, the amplitude of the message signal, option D, the phase shift of the message signal. So correct answer is the option B, message signal. So, thank you very much.